go through here is we'll give you a little overview of what our system is. We'll put you for a ride in one of our stock M1151 series Humvees, which is a standard Humvee that the Marine Corps is using right now. And then what we'll do is we'll put you into a vehicle that's been modified to have what we call a fully active or force inserting suspension. And what that'll do is it'll show you what a ride is like with improved mobility. And what we'll do is we'll let you compare a stock Humvee to an improved Humvee so you get an idea of what the difference is and what the benefits of our system are. The standard gaps that you see that the military is experiencing is they've seen safety issues associated with the existing Humvee fleet. Our company, L-3 Electronic Systems, is not in the passive suspension business. We're in the business of making semi-active suspensions and fully active suspensions. What makes our suspensions unique in the marketplace is we're the only company that can provide both semi-active and fully active systems at the same time. And our semi-active systems can be converted to become fully active systems on a vehicle. Improving the safety of the vehicle by improving the stability is a key design goal. So now on a vehicle, what we call our ECASS, or electronically controlled active suspensions, you can have a vehicle equipped with an all semi-active suspension. You can have the vehicle equipped all fully active, or you can have some of the wheel stations being semi-active and some of the wheel stations being fully active. And that's what's unique to our system. By putting force into the system, or a motor, you can now have what we call force insertion. And what we do is we have a sensor on the vehicle. As the vehicle encounters an obstacle like a rock, the vehicle will start to pitch up. The sensor will detect that, and the motor will physically command the wheel to raise off the ground, go over the obstacle, and as the vehicle starts to pitch down, it'll command the wheel station to drive down. So it'll hold the vehicle platform stable as it's moving over terrain. So if you think about the difference now between that and the previous generations, in a passive suspension or in a semi-active suspension, when you encounter the rock, you hit the rock. The force of hitting that rock is now coming into your vehicle. And what you're doing is you're dampening that force through the dampener, the shock absorber, or the spring. In a force insertion system, you encounter the rock and the wheel is physically being raised over the rock and then driven down the other side. Another one of the benefits that we have in our system is what we would call improved survivability. And that comes from the fact that, again, because in a fully active system you have force insertion or motors in the system, you can now raise the vehicle height higher than it traditionally was off the ground. Anybody can raise the height of a vehicle off the ground. The trick is to hold the vehicle stable once it's off the ground, because again, as you increase the height of the vehicle becomes unstable and it will roll as you hit evasive maneuvers. But again, because you have force, you have motors there, you can physically push and pull on the vehicle, and in so doing, that allows you to maintain stability of the frame. So we can run at an increased ride height off the ground. If the driver has a mission profile that requires him to accomplish a certain distance in a certain period of time, that forces the drivers essentially to move on road in order to meet the mobility requirement. Moving on road makes them predictable, making them predictable makes them subject to attack, and the cycle continues.